Welcome back. Today we're going to start the first of two laboratories that we do regarding soil. This has to do with our Earth unit, and as we study the Earth's crust, we study the atmosphere and weather. We also study, when we start to get into plants and how plants grow, the first foundation that we need to understand is that no life on Earth can exist if it isn't for that top 8 inches of soil where practically all of our plants grow. So, we're going to do two labs that go with this. The first one, you can look this up online. It's usually called the Mason jar test, which you can find a few worksheets out there on that lab if you'd like. Or you can look it up under what I prefer to call it as the shake test. This is very simple. You get your students, or you can find, in this case, an old olive jar or a mayonnaise jar or a pickle jar of about this 1 quart variety or so, 2 pints, somewhere in that neighborhood. And we're going to fill it about half full with soil. In this case, a student named Mercedes brought this from near her house down by Hagerman, New Mexico, which is just south of Dexter on New Mexico State Route number 2. And we're going to take some of the soil out, put it in a beaker. We're going to use that for our chemical analysis lab, which is after this one. Okay, this lab involves some measuring and some mathematics. So the first thing we do is we're going to take our raw sample, get it fairly even in the jar, and then, using our ruler, of course on the SI or metric side, we're going to lay our ruler alongside, and we're going to measure how deep is our soil sample. In this case, approximately 6 centimeters deep. And so we're going to write that 6 centimeters here on our laboratory form. Question number 1 was, where did it come from? Whose house was it in? The yard, a field, near the road? Give as much detail. Now, one thing I will say is that when you're asking students, or when you're trying this at home, find a place that doesn't have too much vegetation on the top of it. And you need to dig down the first inch or so, because in our area of the country we get a lot of blow dirt that blows in the wind, especially today when the wind's blowing 30 miles an hour. We want to get underneath that and get into the real soil that's underneath. So that's just a little hint there. The next thing that we're going to do is we're going to add water to this. Now this is a very simple laboratory to do. So we're going to crank up the water, take the lid off. We're going to add water up here to the shoulder. We need to leave a little air gap at the top, but we're going to add a little bit of water at the top. And then basically we're going to start shaking this. See if we can't get that loose. There we go. We want to make sure that we get the water all the way to the bottom. We had some students that did this and they had pockets of soil that never did mix with the water. So once we've done that, we're going to take the lid back off, add just a little bit more water into it, because we want to make sure we have enough water, and we're going to shake. And we're going to shake this for a good 15 to 30 seconds. We want to make sure and get all of the soil incorporated. And I'm shaking. And I'm counting in my head. I'm up to about 15 now. So I'm going to go about 5, 4, 3, 2, 1, and we're done. Okay, what are we looking for? Soil is made of 3 particles. The basic particles of soil are sand, the largest particles, silt, kind of the medium-sized particles, and clay. Those of you that work with clay, or you've worked with Play-Doh, or you've worked with modeling clay, may not realize that clay is made of very tiny particles. Eroded, I believe it's limestone according to our book. So what we're looking for is we're going to see what proportion this sample is of each one of the 3 particles, sand, silt, and clay. Then, on the back side of our sheet, we're going to use what's called a soil triangle. All you have to do is look online to find a soil triangle. They're out there, they're available for free on the internet. This triangle measures the sand, the clay, and the silt, And then once you arrive at a percentage of each, you basically just go across until they intersect, and it tells you what type of soil you have. The best type of soil is this one here in the middle. You probably can't read it, but it's called loam, L-O-A-M. In our particular area of the United States, I tell my students that if we are one on any side of this loam, we're probably doing pretty good. Although we do have some students that had everything from just clay to almost just sand in our sample. Silt, not so common in the western United States, believe it or not. So while I'm talking, you will have noticed, and you're going to get jerky here, so just bear with for a second. What I'm doing is I'm taking you out of the tripod. I'm going to set you down here so that we can kind of look and see what's happening. Alright, so within the first couple of minutes, we've already seen water forming up here. So all of our larger particles have dropped out of the liquid and are now settling to the bottom. We're going to let this sample set overnight. It will come back in the morning, and before school starts I'll bring you back in here and we'll see how this does after it sets overnight. But already in this sample, the largest particles, the sand, have fallen out, and they should be somewhere in here. The silt particles will end up in this area, and if we have any clay in this sample, we're going to get a very thin, light layer across the top. Then what we'll do is we'll come back and we'll use our ruler, and we're going to measure again the height of the total sample, because we found that in some of our samples they shrank a little bit as the water took the air out of the space between the particles. And we found in a couple that it actually expanded as certain things, the clay especially, swelled up a little bit. And what we're going to do then is we're going to determine the layers, divide that by the total depth to get a percentage, and then we're going to use our soil triangle. Alright, so we're supposed to wait 5 minutes and then measure the soil sample again. Well, I've been talking approximately 3 to 4 minutes, so let's just go ahead and, using our ruler, let's measure again. And our soil sample now is not 6 centimeters, but this has actually grown to be about 7 centimeters. So on our paper we're going to jot this down. How deep is it? 7 centimeters. And I want to look here and see if I see any layers, and actually I do. Now I don't know how well you're going to see this on the camera, but I see particles of sand from the bottom up to right about here on my sample. From here to just on the top, I don't know if you can see this light line forming up here, but we're starting to get a clay layer. But from right about here to here is my silt layer, and I'm seeing just a really teeny tiny clay layer forming on the top. But again, we're going to come back tomorrow and we're going to measure this in the morning and see how this goes. So I'm going to put you on pause for a minute, and when I come back in part 2, we're going to take a look at several samples that the students did about 2 weeks ago and see exactly what happened in them. So hang on for just a second.